Java engine. As for ABAP engine, we have different applications that created for automation of different business processes. So we have ERP system for automation of HR and financial processes and etc. And as for the Java engine, it is created mostly for the integrating different business applications. So for example, SAP portal application, using the SAP portal, we can make a single sign-on to different SAP and non-SAP applications. So it's probably, if we can hack the SAP portal, we can get access to all the connected systems using a single sign-on. The similar for the SAP PI and PXI, it's servers for connecting different SAP and non-SAP applications. So all the data is transmitted using these servers. So for my opinion, the security of the Java engine is more dangerous than security of ABAP engine. But the problem is that most people, most researchers and administrators focused on ABAP engine, and there is still not so many information about the hacking Java engine. But the problem is that hackers will find other ways. So if the ABAP is widely known, the people, it is becoming more secure, but then the hackers will try to hack the Java engine. So normally the Java engine based on the NetWeaver application server, and NetWeaver application server is some kind of Apache Tomcat application server, but 100 times harder and complex. So we see that there is the application server can store the data about the users in the database, in the LDAP directory, or in the other ABAP subsystem. Also, we have used the Visual Administrator tool to administer server, and we have a HTTP for the connecting the server. And we also have many other different tools and protocols, but there is the main. And as for the administrator's point of view, we have such walls like encryption, user management, and remote control. But we won't talk about how to secure it. We want to break it. So for the attacker's point of view, we have just two big targets for the attack. First target is the open ports for internal attacks, and the second target is the web applications for external attacks. So let's look deeper. And as for the open ports, there's a list of all open ports opened by default when you install the SAP Java engine. And you can try to exploit this by using the fuzzing or sniffing or other kind of things. And the problem is that by default, all the data is not encrypted in these protocols, so you can easily intercept all the data by. And we found one vulnerability in P4 protocol. P4 protocol is the SAP's protocol which is using for connecting Visual Admin tool between Visual Admin tool and the SAP server. So by default, almost all the data is not encrypted and transmitted in clear text. But the problem is that the password is encrypted, and we try to understand how is it encrypted. And this is a screenshot from the Wireshark, where we found that this place where the password is encrypted password is placed in the packet. So we begin research in the area of understanding how the encryption is going on. So we started from the create the password with symbol A, send this password, and look how and see how it looks when encrypted. Then we try to send the password AA, send the password AAA, and such kind of simple things to understand, is it encryption or is it just, is it hash algorithm, is it what it looks like. And we found that it was looking like some kind of base 64. And then I realized that it's much easier to reverse this algorithm just by finding the place in the source code. And we just decompiled the Java code and found the code for the encryption. And it's pretty easy. This is the old code of the encryption. And all the encryption is based on the special secret mask value. This value is the same for all installations. So, and to generate a new symbol, we just take a first symbol of the password. We take a mask, secret mask. We take a mask in the power of the first symbol. And that's how we get the first symbol of encrypted password. Pretty easy. So we just created the decryptor for this algorithm, and it is published. It's published in previous slides from the Black Hat. You can download it, all this information, but I just have no time to talk about this more. We have any new demos. So let's forget about the internal attacks and try to hack SAP from the internet. So I hope that people now understand that the SAP can be accessed not only internally, and there is the Google search strings that we can use to find the SAP servers in the internet. Some of the strings are known before, some of them are founded by us and they are new. So, and what we see from the internet is the NetWeaver application server, and by default there are many web applications installed in this application server. So in the version 7.4 NetWeaver, there are more than 300 web applications installed by default. And every this application is kind of a simple website. So you can understand how much vulnerabilities possibly can be found in the SAP Java engine. But it's not all. In the 7.0, 500 applications. Next version, 800 applications. And the last version is 7.2 is 1,200 applications. Each of them is like a website. So it's unreal to make it secure, I think. But and we started to finding vulnerabilities in these different applications, and we started from the information disclosed. We found some ones. Using them, we can find the information about the version of Java engine and the version of application. The red one is we cannot disclose, and the green ones we can disclose, because the red ones are also patched by the SAP. And also we can obtain the application logs and traces using information disclosed ones, username, and create internal port scanning. So this example of information disclosed. This is MW04. It's a version of NetWeaver 2004. Next is also a version of NetWeaver SAP portal and the internal IP address. So we can obtain the internal IP address of the external server. What we can do with this? We can use another vulnerability. By calling this vulnerable GSP page, we can put the IP address and the port in the parameters. And this application will try to connect to this IP address and the port in the internal network. That's how we can scan all internal network using the vulnerable application server from the internet. And we can see different responses in different situations. But if host is not alive, we can see connection timeout. If port closed, we can see connection refused. If it's HTTP port, so we can scan all the internal network in this vulnerability. And another one is information disclosed. We can see the username. MI test user is a technical user for the mobile application. So as for the prevention from these attacks, you can install the SAP nodes, and the main thing you need to disable all the web applications you don't use. Cross-site scripting. There are a lot of cross-site scripting vulnerabilities. It's just a list of ones that was patched by the SAP, but there are about thousands of them are still patching. Prevention, SAP nodes. So next, smbrelay. So smbrelay is a Windows vulnerability. So if we have a SAP server, install it on the Windows box, and if we have a SMB sniffer, install it in the SMB sniffer domain. This is in our computer. By clicking this link, SAP application will try to connect to our SMB server and transmit to us, and tries to authenticate using their credentials, and using the credentials from which the SAP application is running. So in Windows, it's by default it has administrator rights. So just by clicking this link, we can exploit the smbrelay vulnerability and relay authentication to other hosts. And the problem is that SAP applications basically installed on the cluster nodes, and in the Windows there is a vulnerability that this smbrelay is patched. But if we try to relay from one node of the cluster to another node of the cluster, we can do this even as the vulnerability is patched, because it's like the different hosts. So, and SAP servers are mostly installed on clusters, so we can use this. But SAP is closed this vulnerability by using the authentication to this application. Okay, so we just try to use the cross-site request forgery and give this link to the administrator. Maybe he clicked this. Okay, as for the cross-site request forgery, SAP have an API for protecting the applications from the cross-site request forgery. There is a standard cross-site request forgery protection when the server generates a token and the application automatically checks this token. It is working for the simple GET request. And for the other more complex applications, there is a custom cross-site request forgery protection when server generates token, but you need to manually check this. But in most of the applications, this standard protection is using. So we were thinking how to bypass this protection, and the first way is to find the place where there is no cross-site request forgery protection. And there must be the place where it is impossible. So if we have the application with the user interaction we can install the cross-site request forgery protection because we have a session between the user and the server. But if we have some kind of remote API between the two different servers, we cannot use we don't have a session, so we cannot have a cross-site request forgery protection. And we found one place in SAP, so it's called the SPML web service. This web service is created for integrating identity management software with SAP software. So, for example, you want to create a new user in the different systems, in SAP, in domain, etc. You send the request to the identity management server, and identity management server send the XML request to SOAP interface, and XML request is creating new user. So it's good using this XML request to this SOAP page. We can create new users. We can add users to groups, and almost all things with users. But the problem is we need to have the special rights. But by default, we don't have any users at all. We're just trying to pen test the system. Or maybe there is another way. Of course there is. We can create the HTML page with XML HTTP request to the SOAP page, which is creating new user. And then we can find the cross-site request or cross-site scripting vulnerability, and using this cross-site scripting vulnerability, call this page, and then we just try to give this link to our administrator or upload this link in the SAP portal or something. So that's how we can bypass this protection. But unfortunately, the SAP asked us not to publish the request for creating this user, but the good news, you can download it from the internet, from the SAP's recommendations, as we do. So, as for the prevention, you just need to use a firewall and disable access to the SPML interfaces. And authentication is probably the most interesting part of the talk. So, there is two kinds of authentication in the Java engine. Some applications use declarative, when you declare access in the web XML file. And some kind of applications use a programmatic, when you check the authentication using user management engine. So, this is an example of the declarative authentication, and we have a web XML page where we declare we have a resource called restricted access, and we have a URL path admin, and we have methods get, post, delete, and other methods, and we have a role name admin. So that means that only users with admin role can call delete, post, and get request to all pages inside the admin directory. It's pretty easy. But the first problem, there is an invoker select functionality created by the SAP. It was created for the rapid calling, for developers, for rapid calling servlets by their class name. So SAP published information about the possible security issue in this technology and their recommendations, but there was no details. But in reality, the problem is we can call any servlet from the internet, even if it's not declared in the web XML file, by using the class name. So let's try to use it. So, as an example, we have a class name of the servlet, and we have the URL which maps to this class name, admin critical. And we have a restriction that's to directory admin, only admin role can get requests. So it looks like secure, but using the invoker servlet, we can call this URL servlet and the class name. Is how the invoker servlet is working. And by calling this servlet directly, we bypass this restriction. So, and there are many applications where we can find this kind of vulnerability, and we'll show it in the demo. And as for the prevention, SAP created the option enables invoker servlet globally, so you can use this option for enable or disable the servlet, or you can use our free tool to find places where there is a possible bypass. But okay, this is pretty dangerous vulnerability depending on what the service is doing. But I wanted to find something by myself and find something that can be used to hack all the SAP systems, not depending on version of platform and etc. And I found this vulnerability is called web tampering. So, what is about web tampering? So, again, web XML file, URL admin, method get, role admin. So, what will happen if we will use the head request instead of get request? Anybody know? The problem is, if we use head request, it means that there is no head request restrictions. It means if we use head request, so anybody can do head request in the admin directory. This is a problem of our architecture. So if you don't find any algorithm, it means by default all methods restricted. But if you just put get, it means that anything else is not restricted. To use this vulnerability, there must be, first of all, the security control that lists HTTP verbs. Yes, we have the security controls web XML file. The second, it fails to block verbs that are not listed. Again, it fails to, and also the applications must execute head request as a get request. And sometimes some applications do this because programmers just don't care what request is going, if it's head or post or get. They have one function, get request. So it means that the same functionality is going, and it doesn't depend on the methods. So in Network Java Engine we have all these options, and the web tampering is possible. But the next problem is that, as I said before, we have about 500 applications in a version where I was trying to find vulnerabilities. And the problem is to find some vulnerability in this big area. So first of all, the vulnerable application must miss head check in the web XML. The second, this application must use the head as a get, and this application, this request must return, must create something dangerous. This kind of creating new users or deleting some dangerous data. And now, after the first look, we found that about 40 applications are potentially vulnerable. So round one, we're trying to find at least one vulnerability. The first was the head request to do support check service application, we can specify the file name and the directory name. And this application will overwrite this file with a trash value. And don't ask me what's the purpose of this application, because if I try to understand what is the purpose of all the SAP applications, I probably will not stay here. So we just can overwrite any file, and this is example of overwriting the profile file of the SAP server externally without authentication from the internet. Next, we can use the same vulnerability with the smbrelay. So, but it will work only in internal networks. Okay, next, the most interesting vulnerability, and the problem is that we cannot publish the details of this vulnerability until the 3 months will be passed after the SAP will patch this. But it's already patched, and I suppose in the next month we will publish the information. But the problem is we found a secret interface, let's call it secret interface, in the Java engine, which can be accessed remotely without authentication and can be used for managing users and do many other things. But the problem was there was no documentation about this interface, and we just reversed it and found the different commands. And some kind of commands require additional authentication. So we bypass the head, we bypass the authentication using the verb tampering, but for the request we need additional authentication. But some kind of request don't need. And using this request we can add new users, we can create new groups, we can assign user to group, and any other things. So only through head requests we can create new user, assign them to administrator. That's all, remotely from the internet. So I know you like demos, and there will be one. So here is a login page to the SAP portal, and we run our tool called add user. And we specify the URL, specify the user, specify the password for creating, send the request, and try to log in. And we see that application asking us to change the password, because it's the first login to the application. So we just created a new user without authentication in the SAP server. And this vulnerability was working in the internet in different servers, and we have a contract with one of the biggest companies in Russia, and it was a penetration test on the Java engine, and they have a SAP portal in external network, and we found that this vulnerability is really working in the clients, so that's cool. And this vulnerability is patched, but the problem is that there is not only this vulnerability, is the architectural problem. And we found another one vulnerability. It's not so dangerous, but it's also used to web tampering, and it is still patching by the SAP. And I think that there are more web tampering applications, but you need just to find this. But we think that we need something more than Java exploitation, and Dimitry will tell you about the post-exploitation things.
Hello again. First of all, excuse for my very bad English. It's my second security conference. I'm very worried. Okay, great. We can get information from Java, but it's only half. I need more. You need more. All need more. Why? Because some interesting stuff like bank accounts, payment orders, or user credential stored in ABAP tables from SAP. But from Java instance, we can get this information. We can get this information, but we need some user credential, but we haven't it. And suppose we external attacker, we know some SAP vulnerability, but we don't have a user. How we can get on the ABNP if we don't have a credentials? Let's remember all interface between Java and ABAP. Remember. I forgot to say why we can't just create user, how Alexander say. In our situation, we have dual stack instance in SAP service. We have Java instance and we have ABAP instance. In this situation, all user management engine located on ABAP side, and so we can create user with head request. As Alexander say, go on. We remember all interface between Java and ABNP, and we immediately come across with RFC. What is it? RFC, or remote function call, is a SAP interface protocol which simplified the programming of communication process between systems. The RFCs enable you to call and execute a defined function in a remote system or the same system. Okay, you all know about ABNP RFC call, but what about Java RFC? Yes, it exists in the J2EE engine. So, the RFC function is implemented by the RFC provider service, which used for processing ABAP to Java request. A feature is provided for restoring calls from the SAP system. This is done by registering the J2EE engine as a RFC destination. It's what we want. It's our bridge from Java to ABAP. But we again have a problem. We need a login and password for RFC call. It's very bad and very sad. But we have a secret interface. Early we think we can only use management through this interface, but we little bit research and found a more interesting function, far more interesting action. What we can do through this interface. First of all, we can execute operation system command on the server side. Yes, we can management server operation system through head request. It's very cool, but our goal is not operation system. Our goal is information from ABNP tables. Next, we can create own Java RFC destination, warmer, but I remind, if we create own Java RFC destination, we need to point some SAP user for executing function. But we don't have a user, it's a problem. And next, we can read properties of existing Java RFC destination. And bingo, it's what we want. Why? A little bit later. And most interesting, all this action we can do without authentication. It's very cool. Authentication, what is it? Okay. we can read properties of Java RFC destination. So what? For RFC call, we needed a user, SAP user. And when we create a Java RFC destination, we point the username and we point a password. And all this stuff located, stored in Java RFC properties. Usually, SAP administrator use for this user very critical and high privileged users like a substar or different name user with SAP all profile. And all this stuff, as I say, stored in Java RFC destination properties in clear text. And we just can easily get it. In the screen, you see how RFC destination, Java RFC destination properties look for SAP administrator. First of all, he needed login in SAP Visual Administrator Tools, find Java RFC destination, point some server info like a host name, client number, language, blah blah blah, and username and password. And we needed username and password, and we can get it. On this screen, you can see how we can get this information. We don't have username, we don't have password. We just say to SAP, hello SAP, please give us all information about Java RFC destination, and SAP return to us all this information. He's returned Java RFC username, Java RFC password, and other information.
So we're just using the internal API for reading the RFC destinations. So we read the usernames, passwords, and the RFC destinations in clear text. So, okay, we have all this stuff, but what we can create with this? We can create a little SAP backdoor and realize it as a Java class. And which can do this backdoor. He can get Java RFC destination user and password from properties. Done. With this username, after that we have a username and we have password. After that we can using this credential for connection to a BAP server. Great. And finally we can read any ABAP table. It's what we want. We can read, for example, we can read any table. We can read, for example, user02 table when stored all SAP user information like a name, like an encrypted password. We can read financial tables like LFBK, where stored bank information, payment account, and other interesting stuff. We can't read any system table like RFCDS. In this table stored options for ABAP RFC destination. It's very cool. Many interesting info stored in ABAP table. And finally, because it's backdoor, we can create all user with SAP old profile in ABAP engine. After this section, we SAP bug with SAP got. Okay, how we upload our backdoor? As I can say earlier, we can execute command from on server side. We have remote command execution vulnerability, and with this vulnerability we easily can upload our backdoor class. We just create a FTP server, connect this FTP server, and upload our class from
mega secret folder with vulnerability application. After that, we can use our backdoor with two head request. Okay, enough was. Show the demo. Take up. Because SAP asks us don't publish vulnerability, we create two Perl scripts for demonstrate. From scripts upload our backdoor on the server side. After that, we can use this. And we just put in script SAP URL and our FTP credential. Run it. I say run.
So we're just doing about the word tampering vulnerability by sending the different head requests.
Our backdoor. Step by step uploading. Uploading. Okay. Backdoor on the side. After that, we can read information. We can read Java RC properties. Against Perl script, just put URL to SAP, then run. All output information write to the TXT file on the server.
We create the TXT files on the server and then read this information.
And we successfully read LC destination properties we stored. We get login username, substar, we get login password, and other information. After that, use this credential, we can do anything in SAP. We can, for example, read table. For example, read all information about SAP user. Table user 02. Execute. And read all information. Perfect. Voila. All this information. Password and other stuff. We can read any table. We can do, and finally we can create a user. But I think you trust me. Thanks.
Right. So we just uploaded the backdoor to the Java engine, which is accessed from the internet, and from the Java engine we connect using LFC destination to internal ABAP engine and read this data and upload it to our and read this from the internet. Okay, so backdoor is cool, but how about the SAP worm? So the first concept of the SAP virus was created by Duran Hain in 2002. It was the concept of the virus written in the ABAP code. Then some interesting information about the backdoors and worms was created by Mariano. Last year I was presenting the talk about the Stuxnet style attack on the SAP. It was a concept of the worm which is hacking the user application SAP GUI, and also a Tunga shall show another prototype of the ABAP worm. So it is not new, but we created a new concept of the worm, which is based on the Java vulnerability. So what issues we use? First of all, we use that issue that SAP servers can be easily found from the internet. Second, we use our bypass vulnerability, but it can be any other vulnerability. Second, the business needs to have connections between the different systems for the integration, for the data transmission, and etc. And for this connection, there must be RFC destinations. So we use these RFC destinations with powerful credentials to get more servers. And we also use the default passwords. Why not? So this is concept of worm. So how is it working? The first stage, use Google hacking, find some vulnerable Java servers. Then we upload our backdoor. And up to this stage, we can wait for a long time, because even if this vulnerability will be patched, our Java backdoor, our Java class is still on the server side, and we can still call this backdoor. Okay. Then we obtain the information about all internal RFC connections and try to create the backdoor users in the connected systems and try to get all the connections and all the data, and then we repeat these steps. So, so after the worm is pressed, we need to somehow earn money or earn profit. I'm not so good in earning profits as some Russian black hats do, but I have some ideas. For example, the first, you can change the bank account number in the table to your bank account number, and the next payment we will transmit it to your bank account. It is fast money, but the problem is you can be easily found it. Second, we can obtain the financial information before this publication and play with this information on the stocks. It's very hard to find here if you do these things, but the problem is you need to clearly understand what kind of information you need to download and how to play it on the stocks. You can also sell this information to the competitors. Yes, you can earn a big money, but the problem, you need to find somebody who will buy this information. That's the problem. And another one is the neo-source attack. So maybe it is easy. It can be used for activism or some kind of things. And the problem, I don't know, I think there is no problems in this area. Just you can be easily found it. So I think it's a crushing blow on the Java engine. And as for some kinds of prevention from these vulnerabilities, you can install the SAP nodes, which is closing only two word tampering attacks, but it is not closing the architectural problem. The architectural problem still exists. And you also can download our WebXML scanner. So it is created for checking WebXML files against the different misconfigurations.
Okay. As Alexander said, we create a tool to help SAP administrator close and find some vulnerabilities and some misconfiguration in WebXML files. We call this tool ERP Scan WebXML Check Tools. It's free tools. You can download it from our site. What it can do. In this tool we have 9 different checks from information disclosed, auth bypass, intercept critical data, cookie stealing, session stealing, and authorization action and working server bypass. It's all very interesting stuff, but we have not many time.
10 minutes.
Okay. Yeah, I show this. I show you demo. For example, we need to find all.
So it will be an example of how we can find the invoker servlet bypass applications. So we scanned all the web XML files for possible invoker servlet bypass. So if there is no restriction for /* and /servlet*, it is possible invoker servlet bypass. We just run our tool. We can show the previous.
It's local scan, where we can find all links on all vulnerability Java application. For example, look for that. Open this XML file, web XML file, and see. You see defined post and get method, not head. And just 1 moment. And try to get access directly without authorization. Oh, come on. We have a little problem. Here we go. We get some critical stuff with simple query with Vim authorization.
Yeah, it's invoker servlet bypass demonstration.
After that, we can find all vulnerability and misconfiguration of the XML file. Check this after find misconfiguration. Rewrite reconfig web XML, and after that your SAP server will be a little bit secure.
Okay, so as for the conclusion, SAP have different options for securing your data, and you can be secure from all the threats, but you need to do something. You need to read SAP guides. You need to have a regular security assessments or scanning or reading. So it's all in your hands, and it is real to secure the server from this kind of threats, but you need to understand the problem. And many of the different vulnerabilities can be disclosed by us, and I hope when SAP will publish this in the EU conferences, I will show more, and you can follow us in the EuropeScan Twitter or follow me for our future work. And also you can visit the Hacker Harvard conference in Miami. And thanks to all our crew and Hack in the Box crew for this. So if you have questions, we have a time for the questions. Yeah.
What is the difference between, you have to set table
It's a very big difference because free version is just tool which was created by the penetration testers, written in Perl with bad output and this kind of things. And the commercial version is a tool for it's a enterprise scanner for scanning all types of misconfigurations, vulnerabilities, and etc. with a GUI interface written with professional developers. If you want, I can show you the differences then after talk. Okay?
Any other questions from the floor? Right, thank you very much, Alexander, Polyakov, and Dimitry.
Yeah, thank you. Thanks.
Joining us for lunch, which is coming up next.